for this video, we'll do some more graphing examples. So to start off, we have the first case, which is the f prime of x is less than 0 and f double prime of x is less than 0 for all x values in its domain. So this means that your function is decreasing and your function is also concave down. So that would look something like this. It falls from left to right and it's opening downwards. Next, we have f prime of x greater than 0 and f double prime of x greater than 0 for all x values. This means that your function is increasing because of the positive f prime and concave up because of the positive f double prime. So it's rising and it's opening upwards. Next, we have f prime of x greater than 0, which is positive, and f double prime of x less than 0, which is negative. This means that your function is increasing and is concave down, and that would look something like this. Last but definitely not the least is f prime of x is less than 0 and f double prime of x is greater than 0. So your function is decreasing and it's concave up, or something like this. So the concavity is more defined if you try to draw arbitrary lines and try to extend the function as it is. Let's have some more examples. So here we have a vertical asymptote of x at x equals 0 and f prime of x is greater than 0 if x is less than negative 2, but is less than 0 if x is greater than negative 2. Provided that x is not equal to 0. And your second derivative is less than 0 if x is less than 0 and greater than 0 if x is greater than 0. Let's construct the table of signs for f prime. So that is, you have a critical point at negative 2 and it's positive from the left and it's negative from the right. We can also construct the table of signs for the second derivative by plotting 0 as the inflection point and it's negative from the left of 0 and positive from the right of 0. From our table of signs, we know that the function is increasing when x is less than negative 2 and decreasing when x is greater than negative 2. We also know that it's concave down when x is less than 0 and it's concave up when x is greater than 0. This makes 0 the inflection point. Moreover, negative 2 is a local maximum because the f prime changes sign from positive to negative at negative 2. We can now start plotting the graph, starting with our vertical asymptote at x equals 0. And we know that there is a local maximum at x equals negative 2. We also know that it is concave down, so we can graph something parabolic when x is less than 0. And the function approaches negative infinity as it approaches 0 from the left. From the table of sign, we know that beyond negative 2 and provided x is not equal to 0, it is decreasing, so our function must be decreasing beyond 0 and it's concave up. That would look something like this, and now we're done graphing our example. Thank you for watching and see you on the next video. Bye!